Okay, let's start with a question. So basically, I want you to design a cache, basically a cache,
Okay,
uh, where the main specific thing is for this cache is this should be the least recently used cache.
all
So
right.
let's say there should be some capacity of this cache.
Sure, sure.
Let's say there is a capacity of 5 elements.
Mm-hmm.
So whenever we are adding into this, if it is less than five, obviously you're gonna add it.
Yes.
If it is, let's say you don't have enough space there, then you have to remove the one which is least recently used.
So you want me to implement LRU customly, right?
Yeah,
All right.
yeah. Yeah.
So that's all right. I just okay. So we have a capacity for which we need to decide. Okay, till then we have to fill the cache,
Hmm.
and then we. So I will
Hmm.
use queue here and hash here. Hash can be anything. I can use any hash collection, right? So queue
Hmm.
I will use doubly link list, right? And
Okay.
about the implementation. Uh, so do I
Q
have
use as a doubly linked list.
yes
Okay.
because
Okay.
I will explain more on that because
Hmm. Hmm.
when we are talking about least recently used, it has to be reordered frequently, right? Because I
Okay.
have
Hmm.
to
Hmm.
move the items from both the ends. So that's why doubly linked list,
Okay.
right?
Okay. Fair
So
enough. Hmm.
so what I have to do is I have to check each time before inserting the size of my doubly linked list to see if it is already filled
Hmm.
or not. So if it is not
Okay.
filled, that means that I can fill it. And linked list can
Okay.
maintain an order, right?
Linked list maintain an
Order,
order. Is that
insertion order,
doubly linked list maintain an order?
insertion order, like
Insertion order.
the order in which I'm inserting.
Hmm. Hmm.
I'm not saying
Okay.
about ascending or descending alphabetically.
Yeah. Yeah. Got your point. Yeah.
Okay, so what I will do is when it is full, then I know that I have to remove the least recently used one. So least recently
Hmm.
used one should has to be at the bottom, or for me
Okay.
it is going to be at the yeah yeah. Let's say I am
Can
doing
you quick? Yeah. And why you're using hash then? Hash.
so. What hash is going to do is so let's assume a scenario. Let's say I have 1 to 10 numbers that I'm inserting, and let's say I can I will it be okay if I
Or
use a scenario in that case? But
you can do one thing like
yeah,
let me share or
link yeah, it's accessible now. Code share link.
yeah.
So okay. So what I was saying is like first I have to think like if the capacity has been filled or not, right? So what I will
Hmm.
do is let's say if I create a class
Hmm.
LRU, so here I will need public constructor. So what is going to happen is that the doubly linked list and hash set has to be initialized when we are creating the instance, or we are when we are first using this LRU cache, right? And
You
then
write it, I will understand. You write it, we'll discuss.
okay, okay,
Maybe.
all right, all right, all right. So let's say if I do doubly linked list, so I don't have to do it right now. If I can do it in the constructor itself. So doubly linked list. So it has to be. So doubly linked list implementation is already being extended by linked list. So that's okay. Now I have to push. Right. So set many units set does not should not contain this. So, set is not containing this. That means that it is coming for the first time. If it is not coming for the first time, that is mean that it is going to be frequently used. So I have to remove it from the list, from that index itself, and then mhm, index remove किया उसके बाद पुश करना पड़ेगा at the end, पर वो set में से भी
why do you need set?
because I want to check if it is already there or not. So
Okay.
because set is also like a unique collection where it will not have a duplicate. So it meets my requirement there, right?
Okay. Okay. Got it.
What I'm thinking is I have to remove from. Okay, I don't have to remove from this set. All right, got it. So if set is containing the data, I have to remove it from queue. Otherwise,
Q dot remove data. Okay. Why would you remove the data if it is already there?
Uh, because when we say least recently used, what do I have to do is I have to first find out which element I can remove. And for that, if
Got your
an
point.
Mhm.
Got your point. Okay. So basically, if it is not there in set, it means you want to insert this.
Exactly in
So
yes,
you want to remove and you want to push so that it will come at
at
the
the
like
top.
very first
Yes,
top.
yes,
Okay.
very top.
Q dot remove.
So if set doesn't contain the data, so I have to remove in case it is exceeding the capacity. So if size equals capacity, in that case I have to find the last element. So um, item q dot remove last. I will get the item, and this item I have to
Is there,
remove from set also. Are you saying something?
yeah, is there any method saying remove last?
Yeah, I think so.
Okay.
Yes, I think so. There is set dot remove. Yeah, so this should be the code.
Okay, so if set contains data, if it is, let's say it doesn't contain data, then you are q else remove it, then push it.
Yes. So
Okay, set dot add data, so it will come in the front.
mhm.
So if it does not contains,
That
uh,
means that it is coming for the first time.
okay, and if it contains, it means set
Uh,
dot contains.
so
Hmm.
if it
You are
is not
checking the.
So if it is not containing, then these two operations are going to happen eventually at the end,
Hmm,
right? But in case if it is exceeding the capacity, because here I'm checking if it is, because if I do it first, then it is going to exceed the capacity. So that's why I checked
hmm,
if it
hmm,
is exceeding the capacity. So I'm
hmm,
removing from
remove
both
last.
queue and set. So remove
Okay,
last
okay,
returns an integer. Whichever item it is
okay. But
removing, it
but
returns.
this correct, correct. I got you. But this 23 and 24 is always gonna execute.
Exactly.
So
Why?
you want to
Because
execute it always.
I am calling push method. That means that someone wants to push something to the cache,
Hmm.
and it has to be inside my logic how I am accessing or manipulating the data, like the collection that I'm having right now.
So if your very first case, let's say this set does not contains any data,
Hmm.
so it will go to the else and it will remove from the queue.
No,
So
no.
how do you know in the queue?
If the set is
It should
not
not be in the
containing,
queue as well, right?
so if the set is not containing data, it is going to come inside this if not this else.
Okay, okay, okay. Sorry. So if set data does not contain data, it will come here. It will check if the size is not equal to capacity. It will remove
Yes.
that item.
Yes.
Set dot set dot also remove
Hmm.
item also being removed, and then eventually it will push that item into the queue and push the item in our set as well.
Yes.
Then let's say if it contains, then you are removing this item and pushing it so that it will come in front.
Exactly.
Okay, and set that data. And when you like getting any item from this cache, then
Hmm.
what will you do? Because then that would not be recent. That would be the most recently used, right?
So
Getting my
no,
point.
no, no. If I use iterator over my list here, sorry, my queue here.
There in your cache there would be minimum two functions, right? One would be like adding something into the cache. One
Hmm.
would be like getting something from the cache, correct?
So
So can you
here,
write a get, yeah, get
oh,
function for that?
um, I did not get. So if I have to get something from the cache, it has to get entire list or just the item.
How do you use the cache?
So according to me, like when we say cache, it has to store something, right? And then
Correct. But
it has to be used, as in it has to
yes,
uh, what to say? What is the word?
retrieve. You have to
Retrieve.
retrieve the
Yeah,
item from there, right?
retrieve.
In
So
the real world, you won't save a cache as a single entity. You won't save only an integer there, right?
mhm,
You put some keys, some values around that, and when you need something related to that queue, you get the you retrieve that element using that key and get the actual element what you want to use, so that you don't have to go to your backend services and do all those computation and all. So let's say here we don't have this element and all, but you want to retrieve something from this cache, right? You will say
sure, sure.
to the system,
Mhm,
retrieve, get me the data if I'm passing you this element.
mhm. S-
Because at that point of time, why I'm saying you to implement it, because your least recently used thing will be changed here. Because if you are, what is least recently thing? So if you are getting something from the cache, that means that guy is most recently used, correct?
mhm.
Getting my point?
So here, let me change the name of this method.
Why would you change? This method is fine. How do you
Okay,
uh,
this is the very method which is going to refer. So let's say according to your scenario, we are going and actually we are using something, right? So in cache we don't actually so So, according to me, I'm not saying like not denying with you or anything. I'm saying if I have to refer something, let's say if I have five
Mm,
applications open and I'm frequently switching over the applications, right? So then I have
mm,
to know that this one was most frequent and this one is the least frequent, right? One has to
correct,
be on the
correct,
top, one has to be on the bottom of my collection,
correct,
right?
correct.
So here think of this method as that refer method. So what it is doing is, let's say if I click on my Chrome window right now. So what it is doing is it is actually removing the Chrome application from whatever index it was previously and then putting it at the top because it was just used, right? Recently used. And the other
No, 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 no,
application,
no. Let me tell you. Let me tell you. I think you did not understand what is cache. So what is cache? So maybe let's say user is accessing your application, and
mhm,
he just got this something like he called, let's say, uh, he called one service basically which is returning his name. So you understood like this service has been called by the user
yep,
recently.
okay,
So you add that service in this cache, which is your push method. Backend, like once the user call this, you add this into your cache. That is your push service. Now again you are saying again you are observing the user is again calling this service, and you already know the result of this because you know you have already added this into your cache, correct? So
mhm,
this time you will not call the actual service, and you just go into this cache, look up into this cache and return the value directly to the user. For that you need another get function. There is no any cache without retrieval. Even though if you use any cache distributed cache, whether it's hashmap, redis, anything, there is always a retrieval. Otherwise how would you retrieve anything? You will be just adding into the cache, but how would you use it? Getting my point? So
yes, okay,
let's say user has used service 1 as first, you added here service 1. User then used the service 2, you added here service 2. So now service 2 is on the top and service 1 is at the last, correct?
all
Now
right.
let's say user again using is service 1, correct? Now
Mhm.
what is the least recently used? Service 2, right? Not service 1, because user has just used the service 1. So in that scenario, in your
Okay,
retrieval
so
method, that way,
okay. I got your point. So what I will
got
do
my
is,
point?
yes, yes. So let's say
You
get,
are there only, yeah,
yeah. So I will first provide what I want to get,
mm,
right? So let's say it's
correct.
not data, it's key, right?
Mhm.
So first I have to find out if it is already there or not.
Correct.
So if it is there, then I'm going to, if otherwise I can throw an exception that did,
Otherwise, yeah.
yeah, or I can
Otherwise,
I
you
can
have to.
return
Otherwise, you have to push into this
if it
hash
doesn't happen.
catch, right?
All right, so in
Correct.
that
Correct.
case, I will do else and then I will call my push method and
Correct.
pass on this key. If
And you will return this item.
yes,
Yeah.
yes. So if it is containing, then again I have to remove from my queue as well as when I remove from my queue like this very line queue dot remove data, I have to remove
Mm-hmm.
it from its current index and then I will push again.
If it is in your set, you check in the set. Okay. So you'll remove it and
Yes,
you push it. Yeah. Yeah. That's correct. Correct. Cool. So basically, it will be like like basically recently used.
yes,
Correct.
yes.
Queue dot remove. Okay, it will remove it. You will push it. Okay, so you are using a normal queue. You are not using a double link queue and double linked list queue.
Actually, you can say that this method comes from your double DQ implementation actually, because
And
other
what with the complexity of this whole thing?
again, if we were to say linked list, I think it is ON for iteration part,
Mm-hmm.
but for
Mm-hmm.
removal and addition, it is O of one.
Okay, okay. So it will be like maximum. It will go over fan.
Yeah,
Yeah.
worst could be O of n.
Okay. Okay. Fair enough. Yeah. Looks fine to me. Okay. Okay. Prashant, tell me like how much you rate yourself out of 5 in Java?
5. Okay, I think four. Four would be appropriate.
4 would be appropriate, right?
Yes.
So can you tell me what is different between final and immutable classes? Can you uh, can you make any class immutable?
I can, yes.
How would you do that? Yeah.
So, okay, let me first answer your final versus immutable one. So, final actually is always used when we don't want it to be inherited, right? So,
Okay.
if that's the case, then I want my class to be final, but it is not going to be used, so there is no benefit, right? For immutable class, I can give you a scenario which is string class. So a string class is like the most used class in Java, and it is immutable. And why it is immutable, that's another thing. But to create immutable class, we need few things like we need a private constructor. The
Mm-hmm.
class must be declared final. So that child classes cannot be created, and this is just what I explained in final class when we do that, right? And data members or variables that I am creating in the class, they have to be declared private so that they will not be accessed outside. Um, and
Mm-hmm.
um, and there should be a parameterized constructor. So the private constructor is of no parameter one. So that
Mm-hmm.
I will not create a new instance, but I will provide a public parameterized constructor through which I can actually initialize my data variables, local data variables of that class to use
Mm-hmm.
the instance or to create something. So yeah, these are the steps.
But those variables would be like final or non-final.
Um, data members, okay. So class has to be final.
Mm.
Yeah, data members should be final also.
Correct, right? Otherwise, it
Yeah,
won't.
yeah, yeah, yeah.
Yeah.
Good.
Just give me 5 minutes. I'm getting one important call. Just give
Okay,
me 5 minutes. Okay.
okay, okay.
Prashant, sorry. Like actually.
No, no, it's okay. All right.
Yeah, yeah, yeah. So yeah, so the variables would be like private.
Yes. Private and final.
Okay, okay. I know. Okay, so you know what design patterns, right? Java design patterns.
Not all of them, but yeah, few of them, yes.
Huh. Like which one you used or like recently or like use
Uh,
on day-to-day life?
sure. So, I think singleton, factory, abstract factory, these are the common ones I have used.
What is singleton?
So, singleton basically says that let's assume that I don't want anyone to create multiple instances of my class.
Hmm.
So that's where
Hmm.
singleton comes into play.
Can you just quickly give me an example? You
Sure.
can clear this guy, whatever you have written,
Okay,
and give me the
here. Okay, okay. You want me to
yeah, yeah,
write the code?
correct,
Okay,
correct. You can give me.
sure. So singleton, it so for threaded environment or just normal one.
Uh,
So let me just
what do you say? Yeah, I will see about that
no worries.
environment.
Yeah, yeah. So you
Hmm.
can see whatever I'm writing here, right?
Correct, correct. Yeah, yeah, I am able to see that.
All right, sure.
Okay,
So here,
constructor private.
so this is going to be my instance, and this is going to get used frequently, right? So here, public. Yeah, so this should be the code.
Okay, so this is if you put the instances of a Luna, you are creating a new instance and okay, and if it is threaded,
In that case, I have to make it synchronized. That's
okay,
all.
which
Synchronized method I can use, or synchronized block, whatever works.
okay, okay, just put it there.
So let's assume we are talking about synchronized block.
Okay. Yeah, yeah, this can be also good. Yeah.
But I
Okay,
again
nice.
to make it more foolproof, I can use doubly locked
Mm,
way where we
mm,
can also check.
mm-hmm.
Let's say if two threads are accessing it, like uh, mutually, or you can say at the same instance, then I have, so it can be
Got it.
possible that both of them are finding this instance as null, so I can
Null.
again
Mm,
check inside this if it is null, so that will
correct.
be.
Yeah, yeah, got you. Got you. Okay, got you. Yeah, so uh, tell me like which collection you use most in your day-to-day life? Uh,
So I just used hash set, but I think we all have used hash map frequently, so yes, hash map.
okay. So how many implementation of maps we have in Java collections?
Okay. So map implementation, we have hash map, we have concurrent hash
Mm-hmm.
map, and then weak hash map is there,
Okay.
uh, uh, and then so hash set is also an implementation.
Mm.
Yeah, I think yeah, there could be many,
So
but
is
yeah.
does hashmap maintains the order in session order?
Uh, I don't think so. I don't think it does.
So is there any way to use any kind of map where you can
Linked hash map,
maintain the
linked
insertion?
hash map I can use. Yes.
Okay. Okay. And what about shorting? Is there any map where we
Tree
have the
hash map,
shorting and or
tree hash map.
so what is the by default tree hash map shorting?
Um, by default, I'm really not sure about that. Sorry.
Okay, no problem, no problem. So okay, no problem. So okay, fair enough. And what and let's say okay, then if you know don't know about that, let me ask you another question.
I think it is descending order tree hash map, but uh,
No
um,
problem, it's ascending order. No
okay,
problem. If you are not using day-to-day
yeah,
life, it's okay. I do not judge on that.
okay.
Okay. L- Let me, let's say, we have still time. So let me ask you. I don't ask two questions to everyone, but let me ask you because you have given a uh, correct answer for the very first one. So let me ask you. So
Okay.
let's say there you are going through by a aeroplane. Okay.
Mm-hmm.
So you have list of movies in front of you. Your journey could be, let's say, of 70 minutes, and you
Okay.
have list of movies in front of you,
Mm-hmm.
and you have to exactly give two set of movies which you just should watch within that within that range of time.
Mm-hmm.
Let's say you can see this, right?
Not
S-
yet.
yeah, yeah. I'm just sometimes this is having issue. Like you have to just yeah. Now you can see that, right?
Yeah, I can see a bracket. Yes.
Yeah. So let's say 10, then we have 30,
Mm-hmm.
then we have 60, let's say 40, then 60, and then 50, something like that. So if you
Mm-hmm.
see, right, we
Yes, I
have
can see.
two combinations, either
Mm-hmm.
10 or 60 we can take,
Mm-hmm.
then user can watch within 70 minutes, or you can take 30, 40, correct?
Okay.
But we will take 1060 because it is having one movie which is like of larger time.
Okay.
You got my point?
Yes,
Because
yes.
your time is, or let's say I removed this 40 thing. Just remove it. Don't make it simple. Let me put it 20. So we have only one thing, 1060. So I want you to find these two set of movies which you can watch within this 70 minutes, or it should be the best one. So it could be like 59 also. But this is the best one if you see, like 20, 10 and 59 is 69. If you find the other ones, you will not able to find anything which is better than this. Because we go for 30, 10, 30, 59, everything will cross 70. If you go for the 30, 20 is only 50. So this guy is our best one, 10 or 59, which is less than equal to 70, and which is the best from the other available option. Got my
Okay.
point?
Yeah, actually, I'm just thinking. Yeah, good question actually. Okay, I can think of a scenario, but
You understand the question, right?
yes, yes. The problem is not with the question. I think with the logic. So let me think.
You try to solve with the an efficient way also it will work. Then we will go for the efficient.
Okay. So again, brute force can be used, but again, I have to think of another logic. So let's first do that.
Hmm.
So I have to give out the pair in this case, right? Because in this case, if it is 1059, which is
Hmm.
69, and it is not 70 actually. So,
But it is the best maximum.
mhm.
If you're getting confused by that, let us make it 60. So,
Yeah, because if it is exactly 70, like the sum is exactly
mm,
70, then the logic can be 1, and if it is 59, then it has to be a bit different. All right,
if
so
you want, maybe yeah, tell me.
so all right, so int I equals to 0. Let's say array I am getting. So array
Hmm.
dot length I plus plus. So first, I need to maintain the time. So I'm assuming that I'm getting, so let's say this.
70, 70. Yeah, yeah. Let's keep it 70. Yeah.
So I'm assuming that I'm getting my time in this method as a parameter, right?
Mm-hmm.
So I don't have to bother about much. So
Yeah, I'm only concerned about the logic.
I know.
I want the.
Okay, so now I want to find the difference. So it should be time minus the current index, which
Mhm.
is array of I.
Mhm.
What's happening? Okay, now and you want to get the maximum one. So it's possible that 70 is coming from multiple pairs. Let's say 10,
Yeah, let's
60,
say,
and 30,
yeah,
40
let's
is
say it's
also
only
there.
one pair
Okay, let's
for the
say,
timing. Let's say
okay, okay, for the time. Okay,
either it's there or it's not there. Yeah.
okay, all right. So let me create an array.
How many array will you create, dude? Already you created one set, then array. Okay, result for result.
So
Okay, fine.
yeah, for result. Also, you said time complexity. This is about space complexity.
Yeah, yeah. Okay, no issue. So basically, we'll get this diff. If you see the diff is not there, contains. Okay, okay. Result zero diff. Result one.
Yeah, so this will be the output. Then I will change the return type of this method to int array
Okay.
and return the result.
So your 10, or if it is not in the set, then you are just adding that item in the set so that you can later on, if you found something in the diff like that, so you can return.
Mhm.
Okay. Okay. Got it. So this complexity would be order
O
of
of
n,
n,
but
yes.
complexity would be there for order of n, O of n.
Mhm.
Okay. And let's say if can you think of something if you remove this set? I don't want this complexity as well because you have already list of like 1 million movies, and you again want to create a set for that. Can we think of something?
Mm,
Just think if it is this array is shorted, would it be helpful?
If array is sorted, yes, that would be helpful. Let me check. But again, to sort, okay, if it is sorted coming, okay, 10, 20, 30, 55, 60. So I know
So
that
this
the
problem I
maximum
can
value.
go little bit higher in the time complexity if it is order of O of n. So let's go with O of n log n. That would work for me. But I don't want to use the space complexity here because there could be a, right, there are millions of movie out there in the world,
Yeah,
and so
actually, on that, I don't think we ever encountered space issues because it's good. Like we have around 1 TB, 2 TB space already in our laptops, so it's very
no,
rare.
no, it's
No, I know,
correct,
but
but it
I'm
doesn't
think
work like that.
yeah, I know. Like I never actually write down a
Space is
logic.
always there.
Yeah, that
Space is always there.
yes.
But we have to minimize the cost by any way. They see every problem you have to trade something for something. So it's eventually depends what you want to trade off.
Okay.
If the space cost is much more than your computation cost, then you don't want to, you want to save on space.
Mm-hmm.
If your computation cost is much more than space, then you save on computation and you can spend on space. So that depends on the type of problem. So here we don't want to spend on space because there are much of movies we don't want to store twice, and we know there are solution exists where we don't have to do that.
Yeah, I'm actually thinking like if it is sorted, then again I have
Hmm.
to
Think in that way.
yeah. So if I have to think in that way, like I have to check from the very first and from the very
Hmm.
last. I have to then make
Correct.
pairs, check if
Hmm.
someone is resulting in 70.
Hmm. Hmm. Hmm.
So in that case, I don't have to manage anything in the database. I just need two pointers.
Correct. Correct. You are
Actually,
going in the right direction.
Actually, I don't need two pointers. I need only one pointer. So I know that it is zeroth. I can subtract it from the size to get the last index. And then I can check because like for two pointers, I need two.
That's fine. That's fine. Even though if you get the last index, it's always order of n only. Length
Yes.
will work for that.
Yes.
So you maintain 2 points, or one is left first index, one is last index. And what would be the conditions then?
Um, So condition has to be if the sum of these two indexes are equals to 70, the target.
Hmm. Mm-hmm.
If that's the case, then I will return these two indexes or again result that into array.
Mm. Correct. If not,
If not, then I have to keep go on, else like the loop will continue.
where would you move your loop? You have two pointers now, right?
Yes.
So what would you move? What would you don't move? There would be conditions, right?
Uh,
Or you move both, then you can miss the.
so both of them have to come close to each other till they reach
Hmm.
20 in like the middle.
Correct. So it's the sorted array. Think about that. What should you move? What would be the condition? You know binary search, like you add the things. If it is less than one key, then you move to the left side or right side. You know, right? Because it's already sorted.
I know,
You know
but
where to move.
yes, yes. Okay.
Think in that way. So if it is equal to 70, your zero I pointer, j pointer, add sum up to equal to 70, you know this is your answer. But let's say it's greater than 70. What would you move? You move your I pointer or j pointer?
So, okay, got your point. So,
Hmm. Hmm.
if that's true, like I have to first find out the middle element. So if that middle element is already greater than the target, so I don't
No,
have.
no, you are going at the correct. You are going at the correct. I two pointers. I do not give this many of clue, but I want you to find the answer. That's why I'm giving you. You are going at the correct. Don't go for the middle.
So I have to find out the high and low in that case. What you are saying is,
Hmm.
so in that case, the two pointers that I'm having, they are high and low.
Hmm.
So they will get manipulated whether I have to get the left half or right half. So
Correct.
if I
Correct.
know that the index or the value that I want is at the left part of the array, then I will just iterate over that part itself. I will not
Okay.
bother.
Let me tell you again. So this is your ith index presently be at the 0th, and this is your j pointer which is at n minus 1. Correct. So
Y-
now you sum up it to equal to 70. You just return it. Okay.
mhm.
So now let's say it's greater than 70. You should move this guy or this guy because it's a sorted array. Think about that. It's a
Uh,
sorted array. So if it's
yes,
greater than 70, you are never going to find the
I
solution
have to go to
or
left in
right side of it.
I have to go to left.
You
I
have
have to
to.
move my jth
So
pointer
you will
to
move
left.
this guy.
J.
Yes, you have to move your j pointer to left.
That is,
Correct.
I have to decrement
Uh,
this.
correct. Correct. And if it is greater than, then you have to move this guy because
Ith pointer.
got it.
Yes, yes.
Yeah. So you are going in the right direction. That's why I helped you. But I wanted you to find that thing. Okay, no issue. So in that case, you would have the max order of n. Worst case, if your item is exactly present at the being, let's say in the middle, then order of n. And what would be the
Yes.
sorting? Which sorting would you use?
So here we are using binary sort, right?
No, no, this is for the finding the element. But before that, you have to sort this element, right? This
Uh,
array.
okay, I can use n log n is the best I can get. So quick sort, heap sort.
Hmm. What
Uh,
would be the best complexity you can get in the sorting?
best worst case complexity or just like best complexity.
Hmm.
Best
Let's say you
best
use
could be
arrays
that.
dot sort.
Yeah, best could be that is n log n I think.
Uh-huh. What
Uh,
it does internally use, do you know?
uh,
Arrays dot sort.
I think it uses stem sort.
Team sort and combination of merge sort, I guess.
Yeah, yeah.
Okay. Okay. No issue. Yeah. Yeah, that's all, Prashant. Have a nice discussion with you. Let me know if you have any question for me.
As of now, I don't have any questions.
Sure. Nice talking. Okay. HR will let you know about the
Sure, sure,
feedback.
sure.
Okay.
Yeah, sure.
Thank you, man.
Okay, thank you so much. Have a good day. Bye bye.
Yeah.